See if my tablet's working. So today we're going to graph and analyze power functions and radical functions, and I think that will be easier for you than the second half of the lesson, which is solving radical equations. Okay. These are a couple warm-ups that you don't have, so help me out just with foiling this first disaster. Do you remember some properties here? If I do 4 times square root of 5, is there anything I can do with that? Just write 4 square roots of 5. If I do 4 times this negative 3 back here, what would I have? Okay. What about 2 square roots of 5 times the square root of 5? Yes, because square root of 5 times square root of 5 would be square root of 25, or just 5, right? And then it was times 2, so we ended up with a plus 10. And then this last term times this last term would be a negative 6 square roots of 5. Everybody okay? So in here, these would combine to be negative 2. And these two could combine to be negative 2 square roots of 5. Everybody all right? Okay. We're going to have some garbage like this today. You have to FOIL it out. So real quick, 2 square roots of 2x times 2 square roots of x. Anybody know what that would be? 4x. All right, then here times here, we'd get a negative 6 square root of x. I'm doing funky order, I apologize. There times there is negative 6 square roots of x. And then negative 3 times negative 3 would be plus 9. So we wound up with 4x minus 12 square roots of x and a plus 9. So let me ask you this question, because this is going to come up all over the place today. When we squared something that had a square root in it, did the square root disappear completely? Not if it was a binomial, right? 2 terms. We still wound up with some square roots in this. That's going to be an issue later. And last little warm up, can x equal 4 be a solution to this equation? Can x equals 4 work in that equation? No, because the square root of 4 is positive 2. If it said x squared equals 4, we would have 2 solutions, plus or minus 2. But this is not that question. So you have to be very careful when you're checking your answers later today. All right. This section talks about power functions and radical functions. A power function is simply anything with x to some power. That power can be negative, it can be a fraction, it can be a whole number, it can be really messy, okay? We're going to talk about monomial functions today, which means, guys, while there can be stretching and stuff, there is no shifting, okay? Everything is just going to have one term. So anything that is a power function with a positive integer that's even will look like this. So if I had an x to the 4th, or an x to the 6th, or an x to the 8th, they would all have this shape. And you will have to be able to tell me the domain, the range, the intercepts, that it's continuous. It has what kind of symmetry, guys? Yeah, it's y-axis symmetry, so it's even function. Okay, where it has a minimum because it's opening up, that it is decreasing from negative infinity to 0 and increasing from 0 to infinity. All right, and the end behavior is both ends are going up. And that all switches if we make it n is even with a negative out front. So if we had a negative something, and it could be a number, with an x squared, or a negative something with an x to the 4th, or a negative something with an x to the 6th, they would all just go down and things would change accordingly. Any questions on that? All right. When we have an odd power, like an x cubed was this shape, an x to the 5th, an x to the 7th, they would all be this shape, okay? If we had a negative in front of it, like a negative 6x cubed or a negative 1/3 x to the 5th, they would go this way. But as long as there's no other terms, like something with an x cubed and an x squared and an x, then it can have dips and waves in it. This is just going to be a monomial function, so it's going to go through 0, 0. Is it increasing or decreasing? This one I'm doing on this side. This whole thing is decreasing, yes? Everybody decreasing all of it? Okay. The intercepts are both at 0. The symmetry for both of these functions are origin symmetry, so they're both odd. Everybody okay? All right, so you're going to have to analyze a graph. So the example they give you was 1/3 x cubed. You guys get to use your graphing calculator, so you would type it in and find an appropriate window and graph it. And then you would have to say the domain and range. For this one, it's all real numbers for both. The only intercept is at 0, 0. The end behavior, be real careful. Oh, it's written backwards here from what we've been doing. But it says on the left it's going down and on the right it's going up. It is continuous and the whole thing is increasing because you go left to right, the y values keep getting bigger. All right. One more time, a monomial function with even degree will be even function, and a monomial degree function with odd degree will be odd function or symmetric to the origin. All right, 3x to the 4th, you have this example. If you plot this, you type it in your calculator if you want. Give me some ordered pairs, anybody? 0, 0, if you put in a 1, what are you going to get out? Put in a negative 1, you're going to get out a 3, right? Everybody with me? It probably looks pointy almost on your graph because it goes up very, very quickly. You could change the window, like they have -5 to 5 for the X window and like -6 to 6 for the Y window. It's not a big deal what your window is. You need to help me find domain. Anybody? Yeah, there's no, guys, look at the function. There was no denominator or radical, right? So it's all real numbers. Range, though, what can come out?
Comma,
Brackets.
0.
Okay. The intercepts? Yeah, 0, 0 is both the X and the Y intercept. End behavior. The function goes up as X goes what? Left and right, yes? Any questions on that? Is it continuous? Can you draw it without lifting your pencil? Increasing, decreasing. It's doing both. And remember, these are X intervals where it's doing this. So what is the X value over here? When you start on the left, it is, and is that increasing or decreasing on that side? Decreasing from -infinity until 0. And then this branch is increasing from 0 to the right or towards infinity. I know both ends point up, but it's as you trace it left to right. Everybody good? So you think you could handle one of those on a quiz? It's just a review of graph analysis, right? They do get a little funky here in a minute. We'll talk about a couple, but the reciprocal function, remember, looked like this, okay? It had undefined places. Similarly, you can have things that are undefined and you will have discontinuities, okay? So this one has an odd degree, so actually it still has a discontinuity. This would be 1/5 of x to the -3. We could write like this. So x can't be what, guys? But what's the restriction on the domain? X can't be 0 because you'd be dividing. Okay, somebody graph this bad boy and tell me what you get. Is it doing just the same places that?
It's very good descriptions.
Okay. I don't think you're going to get any nice ordered pairs, are you? Yeah, it's very, very tight here and here, yes? And it goes on in both directions. All right, I hope you can tell it doesn't end. If you can't, it doesn't end, okay? It would continue because there's no restriction besides 0 on what you could put in there. Yours may look like it ends, but it doesn't. All right, so let's start with domain and range. If I was writing it the fancy way, domain is everything up to 0, but not including 0. Or you could just tell me x can't be 0, unless it says to put in domain, which I think it does. Range is what? Same thing, yep, because you're not going to get out of 0. It has a horizontal asymptote of the x-axis as well. Does it have any intercepts? Okay. End behavior. F of x is approaching what as x goes to the left? What is it getting closer and closer to? Yep. F of x is doing what as x goes to the right? It's also approaching 0. When you get to calc, you might have to put whether it's approaching from above or below, but you don't have to do that now. All right, it is not continuous, right? Increasing and decreasing. Whew, this is really hard to tell. But one branch is doing one thing and one branch is doing the other. If you were to trace, anybody who's put it on their calculator, if you start out here and you trace going this way, the values are getting more and more negative. Even here, they were getting further and further from 0 and getting more and more negative. That one is decreasing. And that is from where to where? Negative infinity until 0, yep. And then it's increasing. Again, no, I'm totally wrong. Look at this branch. If you put in a value up here, what are the y values going to keep doing? Getting smaller and smaller and smaller, closer to 0, but they're going down. It is also decreasing from 0 to infinity. That entire thing is decreasing.
So, wouldn't part of the other one be increasing? No, because they're still going down.
The y values are getting more and more negative. And here, they start up high, but they still get closer and closer to 0.
If you pick 2 points, they'd be going kind of down.
Yes, yes. Even 2 points that were very close together. All right.
It would have to be flipped around. They have to be the opposite.
If you had a negative in front of the whole thing, then it would have looked like this, and this would have been increasing and increasing. Yep, good call. All right, recall that. Okay, we did this stuff yesterday, like x to the 2/3. Remember we talked about what that means? Okay, a rational exponent, meaning the fractional exponent, okay, in simplest form indicates the cubed root of x squared. If n, the bottom number, is even, then the domain and range are restricted. All right, a radical function basically is anything that has a square root or a cubed root or anything, including ones that you write as a fraction. So exponential form would look like this, radical form would look like this, and all of these are radical functions. Everybody good? They all have a square root somewhere. They're not all monomial radicals. All right, so we're going to study monomial radical functions. If you have an even, so you have a square root or a fourth root or a sixth root, the shape will always be like this. Domain and range are only positive. They do cross at 0, 0. It's hard to tell on my picture. They are continuous from 0 to the right only. They have no symmetry. The entire graph is increasing. There's a minimum at 0, 0. And the end behavior would only have one end. As you approach infinity off to the right, the function is approaching infinity.
So is there no negative?
If you put a negative out in front, yes, it would change everything. You could put a negative out in front of it, and that would still be yes. But this is when it's odd degree. So if you have a cubed root or a fifth root or something like that, then it has both branches because you can take a fifth root of a negative number. So the domain and range are both infinity, they're all real numbers. It is continuous, it goes through the origin. This one is increasing the whole time because even though it slows down its increase, it does keep increasing the whole time. And the left end is going down and the right end is going up. All right, so type this in and try to find a couple points you can graph or just do a quick sketch. I really don't care. And then start going through the graph analysis. This is the kind that could be on the quiz, guys. All right, it was the cubed root negative. Cubed root is under math. Whoops, yep. Okay, Hofbauer, do something here. Negative, okay. Cubed root of 2x plus 5 quantity squared. All right. If I do a standard window, this is what I get. If I look at the table, I don't have hardly any nice points, but I could definitely plot a couple things. 3, -1, and 2, -1. But in between there, it's not going straight, right? If you trace over here, if you put in -2.5, it does hit here. So real quick, at -2.5, it's hitting, and then it's going down this way and down this way. All right, so help me out. Domain? It's a cube root. Is there restrictions on what we can put into a cube root? No, and it goes left and right, so it's all real numbers. Range? Anybody? And it does hit 0 here. Intercepts. This is the one students get wrong because you have to find them. This one is -2.5. So the x-intercept is at -2.50. But the y-intercept, it does cross the y, right? How do you find the y-intercept on any graph? That's interesting. How do you find the y-intercept, guys? It's when x equals 0. So if I go trace 0, enter, I have a lovely negative 2.92 or 924. Nothing nice. Somebody remind me what that was. 2 point, like that? Okay. End behavior. What are both ends doing? Going down. So y goes towards negative infinity on both ends, both as x goes to the left and as x goes to the right. All right, increasing, decreasing. It is continuous as well, but doesn't ask that. Okay. It is both. Coming from the left, it's doing what? Increasing. And it is doing that from negative infinity until, what was the x-intercept? And remember, increasing and decreasing, you only need parentheses anyway. And then it starts decreasing from negative 2.5 to the right. Yes, no, we got it? So it's basically graph it on your calculator and do graph analysis for that whole section. All right, remember, if you're taking a square root, the domain and range will have restrictions. All right, we're moving on to solving radical equations. A radical equation is any equation that has a radical in it. So a square root, a cubed root, a fourth root, a fifth root. Equation means it's going to have an equal sign. Okay, to solve those, first you're going to isolate the radical expression, and then you're going to raise both sides to some power to eliminate the radical. But when you raise sides of an equation to a power, sometimes you produce what's called extraneous solutions. So I Googled extraneous solutions to see if they had a better definition. And it says extraneous solution or spurious solution is a solution such as that to an equation, okay, solution to an equation that emerges from the process of solving but does not actually plug in to solve. Okay? It doesn't work. When you square both sides, sometimes you get extra solutions. Because if it had a square root in it, can you put a negative number into it? No, but when you square both sides, you suddenly can get a solution that doesn't check. All right. One way to check these is by graphing them on a calculator, okay? And I'm fine with you checking them that way, but if your algebraic work does not match your answer, you will not get credit, like zip, for doing that problem. All right, this one I want you to just watch me. Be real careful. It says here, watch out, when you square this side, we're going to have a mess, okay? I want everybody looking up here. Please don't be doing something else because I don't want to have to do 6 of these together and make you write them down. So I'm trying to show you one where I just do it. We're going to square this side and we're going to square this side. We have to do that because if I tried to move this radical over here, so I had square root of x minus 2 plus the square root of 15 minus x, if I square that, do you understand that I'm not going to get rid of the radicals? I'm still going to have a middle term that has a square root of this times square root of that. It'd be a hot mess. Okay, I'm not going to get rid of them the way it's set up either, but it's going to be closer. All right, square root of x minus 2, quantity squared. Everybody watching? What happens over here? Okay, over here, I have 5 minus the square root of 15 minus x times 5 minus the square root of 15 minus x. All right, I'm going fast, but help me out here. X minus 2 equals 5 times 5, okay? Inside and outside are both minus 5 square roots of that garbage, right? And what about this last term times this last term? Well, it's minus times minus, which would be plus, and square root of 15 minus x times square root of 15 minus x is just going to be 15 minus x, which we don't really need those parentheses, but it is, that's where it came from. All right, we have a hot mess. Let's see, x minus 2 equals 25. These I can combine. So I have minus 10 square roots of 15 minus x. Back here I have a plus 15 and a minus x. What do you want to do next? We're going to add this x over here. So we get 2x, okay? What is 15 plus 25? 25 plus 15 would be, and then we need to subtract it over here. So we'll have a negative 42. Over here we have equals negative 10 square roots of 15 minus x. What I'm trying to do is now isolate this radical because I'm going to have to square everything again. Do you want to cry yet? I do. Now, we could, at this point, divide everything by 2 because they're even, but I'm just going to keep going because I like painful math, right? Okay, 2x minus 42. I'm going to need a calculator. You guys got a calculator? Okay, 2x times 2x is 4x squared. 2x times a negative 42 is minus 84x. Did I do that right? Inside here is another minus 84x. Okay, 42 times 42. Okay, on the right-hand side, when I square this, do I have to FOIL that? No, because it's really, I don't even need to write it. I'm squaring, it's a multiplication problem. So negative 10 squared would become 100, and 15 minus x square rooted would become just, but it is a quantity, so we are going to have to distribute that 100. Okay. Hofbauer's going to start sobbing any minute here. All right, if I distribute over here, I have 1500 minus 100x. Over here, I have 4x squared. What is that, guys? Negative 168x?
Yeah.
Okay. If I add 100 over here, if I subtract 1500 over here, did I do that right?
Yeah.
Okay, can I divide everything by 4? What does this become? Oh, thank goodness, because factors of 66, anybody?
11.
So I got x equals 11 or x equals 6. Now the question becomes, do they both check? Okay, can you remember what they were if I scroll back here?
11.
Okay, if I put an 11 in here and here, I will have the square root of 9 equals 5 minus the square root of 4. What's the square root of 9?
3.
Equals 5 minus 2. Does that seem okay?
Yeah.
All right, what was the other one?
6.
So the square root of 6 minus 2 equals 5 minus the square root of 15 minus 6. Okay, this would be square root of 4 equals 5 minus the square root of 9. So 2 equals 5 minus 3. Is that working? Those both worked. Okay? That was a lot of painful algebra. Okay? Not one that complicated. No. There is one that you have to square twice. If you graphed it and zoomed in enough, okay, you would get this, and then you could calculate those 2 points of intersection, and there would be 6 and 11. Okay? You can, but you're not going to get credit until you do the algebra. Because you have, okay. I have a couple more that you can watch, and I'm not going to do all 3 of these. But what would you do first on this one, guys, to make it much nicer? Can you see these? They're kind of small.
You take out 3 numbers.
You can't take out anything because this radical, let's see, you could simplify the radical if you factored out a 9 in there, because you could, but yeah, let's just subtract a 3 to the other side. Now we can square both sides. Everybody with me here? Okay, what do I get on the right? 18x minus 18. But over here, I have to multiply 3x minus 3 times 3x minus 3.
9x squared plus
Now this will be a minus 6x, no, minus 9x,
18.
minus another 9x, so we get minus 18x. And then negative 3 times negative 3 is plus 9. Okay, if I subtract another 18x over here to get rid of this one, and add 18 over here,
36.
I have 9x squared minus 36x plus 27 equals 0. Can I divide everything by 9? X minus 3 and x minus 1. Does that work? X equals 3 or 1. Let's see if they both check. And you could graph to see if there's two solutions as well. If I put a 3 in, this side would be 9. And this side would be, somebody type 18 times 3 minus 18. 36 maybe? So what's the square root of 36? 6 plus 3 is 9. That one's working. Okay, let's check the 1 real quick. If I put a 1 in over here, I would get 3 equals 3 plus, if I put a 1 in here, I get square root of 0. Yes? So that works? So they both work. All right, there's one of these on the quiz, and you're going to be so excited to see it because it's straight up easy. What do you do to isolate the radical here? Subtract. So we have the cubed root of 4x plus 8 equals 4, okay? And now you just cube both sides, absolutely. Why is this an easier problem? Because there was no algebra on the right. So we end up with 4x plus 8 equals 64. If I subtract, someone help me, 56 and 14. Is that right? 20, I think that's right. Okay, so if I put a 14 back in, I'd had 56 plus 6 is 64. The cube root of 64 plus 3 equals 7. Is 4 plus 3 equals 7, and it checks. Okay? Yeah, there's one of those, but there's also a Nikki one on the quiz. All right. I think I'm going to skip this one so we don't run out of time. We're already low on time. All right, so we're going to do number 4. Quick. You have this one. Cubed root of x squared minus 1 equals, what do I need to do? Add 6 over here so I get 2. Now what do I need to do? Cube both sides, and I will end up with what equation? X squared minus 1 equals 8. So x squared equals 9, which means x equals, be careful, it was an x squared, so it is plus or minus 3. Will they both check? Well, what's the first thing to checking them you do? Square them, so you'd get 9. Minus 1 is 8. The cubed root of 8 is 2 minus 6 is negative 4, right? Because you square them first, it could have been negative or positive. 1 down. Okay, this one is also easy. Because what happens? You just square both sides. There's no extra algebra on the outside of the radical, so we just get 6n minus 3 equals negative 15 plus 7n. Solve that. What do you get? 12 equals, yep. Okay, if I plug it back in, it isn't pretty. It's 72 minus 3 over here. And negative 15 plus 84. But guess what? It is gross, but it does work, okay? All right. This one, it gets nastier. It's not the worst. Okay, what do we have to do first? So we end up with 4x minus 21 equals the square root of 56 minus x. Okay? So when I square both sides, can anybody figure out what we get on the left? 4x minus 21 times 4x minus 21 is 16x squared. And that would be 84 and another 84. I'll write them both out. Plus, because negative times a negative is a positive, and 21 times 21, I believe, is 441. And the right-hand side, we just get rid of the radical. All right, so I'm going to subtract 56 over to this thing, and I'm going to add x over to one of these guys. So I'm going to combine all of this. So I have a 16x squared minus 167, maybe? And 441 minus 56 is... Okay. I did this problem this morning just to make sure I could go through it quickly. And I wanted to cry because nothing divides out or simplifies. Do you know factors of that? It would probably be fast to do quadratic formula. But what I did was I typed the original problem. Actually, I typed this parabola in. And I think do 385 divided by 11. Or was it 15 or something? 11 times 35? Yeah, I don't think it was. Because this was like 16 times 1, I think. 16 times 11. What's 16 times 11? Minus 35. That's not going to work, right? Shoot. All right.
Maybe it is.
This is what I did to check, guys. What is the question? 16.
X squared minus 167x plus 385.
Because if I can find one of the zeros, I should be able to factor. Oh, right there. 1, 2, 3, 4, 5, 6, 7. I think 7 is a 0. So, what's 385 divided by 7? So, x and 7. So then we'd have a 16x to make a 16x squared. And 385 what? Okay. I would have just done quadratic formula. Somebody try this. 16 times 7. What's 16 times 7? That would be a negative. And in here we'd have a negative 55 x's. And that would get us back to the negative 167. Okay. So the two exact solutions after painful work are 7 and what does this mess become? 55 over 16, and that doesn't reduce. Okay, the question is, do they check in the original problem? This is what we're going to do. We're going to go back here. We're going to put the original problem in. I'm going to put the left-hand side and the right-hand side. Actually, yeah, that's what I want to do. What was the original question, somebody? Yeah, the left side of the original equation, 4x, was that it? And the right-hand side? Okay, so I'm going to try a standard window. Okay, what were our solutions? They were high, right? Okay, I think the X window is okay. I think we need Y window. I'm just picking a number that I can type on my stupid. There's a solution, right? Trace to 7, and it works, okay? What was the other one we had? Trace to 55 over 16. And it does not work, yes? It's not on the same spot. Okay, so it only had one solution. This one did not work. You don't always get to throw away the ugly ones. By the way, if I put it back in here, if I put 55 over 16 in there, I'd have 55 fourths minus 21 on that side. And over here, I'd have the square root of something. I tried it. What happens is this side comes out negative, and this side is positive. That's why it doesn't work. All right. This is the miserable one, guys. Please, no. We're going to move one of them over to the other side. So we have square root of 6x plus 12 equals 1 plus the square root of 4x plus 9. What happens when we square the left side? We get 6x plus 12. The mess is when we square the right. Okay. 1 times 1 is 1. Square root of 4x plus 9 times 1 is one of those. Plus the other 1 times 1 is another one of those. And then square root of 4x plus 9 times square root of 4x plus 9 would just be 4x plus 9. Okay, I'm going to subtract the 4x's over here. And over here there was a 1 and a 9 that I need to get rid of. So that's gone, and that's gone. What's left on the right-hand side is 2 square roots of 4x plus 9. On the left is a 2x plus 2, anybody? Okay, good news. Yes, I can divide everything by 2, so this becomes x plus 1 equals 1. The radical doesn't change. Okay. Now I have to square again. What does the new right-hand side become? Okay, x plus 1 times x plus 1, that's the left side, would be x squared plus 1x plus 1x would be 2x. And the right-hand side, 1 squared is just 1, and then the radical goes away. All right, if I make that equal to 0, how does that factor? I subtracted the 4x over here and the 9. Factors x minus 4x plus 2. So what do I get? X equals 4 or negative 2? Okay. Can I go back to the top, guys? I have seconds, right? If I put a 4 in, I get square root of 36 minus square root of 25 equals 1. That'd be 6 minus 5 is 1, yes? What was the other one? 2? Negative 2? If I put in negative 2 in, I get square root of 0 minus square root of 9 equals 1. Is that working? That's not working, is it? Was it negative 2? So the negative 2 does not check. All right, thank you for listening to me go really fast today. This is the assignment. It is on the homework check sheet. Do it, or you will regret it because you will be retaking this section over and over and over.